Okay, so welcome to this tutorial. We're going to learn how to create Solana MerkleTrees. The idea is that NFT data is hashed and a combination of hash can build nodes, and a combination of nodes, when there is the deepest level, create a MerkleTree root, and this MerkleTree root hash is stored on chain, and all this data of hashes help verify integrity of all the NFT, because if you change 1 byte of data in a NFT data, will change the final hash. So is very strong, these methods. Okay, but first, what is a MerkleTree? The idea is that child hashes are combined to create parent that store the hashes of the children. So each leaf stores the hash of a data block. There is a single NFT. The Merkle root, the single hash at the top, commits to all underlying data. So also you can make quick proofs. So you can use log base 2 of n sibling hashes, not the whole dataset. Why it matters? Because any change in a single byte anywhere forces a different Merkle root. Tampering is instantly detectable. So the inventor of these MerkleTrees was Ralph Merkles in 1987, and he patented this 8-leaf diagram. Okay, so now top use cases for MerkleTrees on blockchains, on Bitcoin, Solana, and Ethereum. So the idea is that the Merkle root will be used to verify the transactions without syncing the whole chain. Also for cNFTs that are layer 2 Solana. So on-chain account stores only the concurrent MerkleTree root. The NFT metadata lives off-chain, cutting cost 20x or even 5000x, and also is used for Amazon DynamoDB, Apache Cassandra, where nodes compare Merkle roots to detect and sync only out-of-date chunks. Why MerkleTrees matter in crypto? For integrity, you can prove anyone can audit that data hasn't been altered without re-downloading it. Light client friendliness. Phones and browsers verify payments with kilobytes, not gigabytes. Scalability. State compression on Solana. Rollups on Ethereum and many layer 2 designs rely on Merkle proofs to keep layer 1 on load. Cost saving. Compressed NFTs store data instead of full metadata on chain. Slashing account rent, similar tricks reduce gas in rollups. And future proofing, the same root can be plugged into zero acknowledge proofs or cross-chain bridges. So the idea of the Merkle tree is that you have a Merkle root. In the base you have NFT data, and it will be hashed, and a combination of hashes are hashed to form a parent that is a node. And then a combination of nodes can form another node. And when you get to the root, that root is called, when you can combine more nodes, you get the MerkleTree root. Okay, so the question, can you hash big data sets or big data? The idea is that Chat256 and OpenSSL that already handle this for security purposes, and the file size won't matter because they can handle even terabytes. How do MerkleTrees work? The idea is that you have leaves that are hashes of data blocks, as we see. Parents hash their children until one Merkle root covers everything. Tiny proofs. To show a leaf is included, you reveal only the logarithm base 2 of n sibling hashes, not the whole file. Tamper evident. If you change 1 byte of data on a single NFT, every hash above it changes, so it will have a different root. So making fraud is obvious. What is Solana Metaplex? It's a toolbox on Solana that is open source. It's a protocol of programs and smart contracts that lets creator mint, sell, and manage NFTs easily. Programs like Candy Machine, Token Metadata give one-click drops, standardized metadata, and royalty rules. Metaplex governance tokens lets the community vote on upgrades and fees across the Metaplex ecosystem. What is Metaplex Bubblegum program? Bubblegum Metaplex Compressed NFT program. Bubblegum Metaplex Compressed NFT program is the program that stores the Merkle root on chain. The NFT mints are 20x or even 5000x cheaper. Keeping metadata off chain cuts rent to almost a minimum per NFT. So they are mass mint ready. It allows games and social apps create millions of NFTs while using standard token metadata. How do Solana compressed NFTs work? Data lives in a concurrent MerkleTree. The on-chain account holds only the tree's root hash. Transfers and burns use Merkle proofs passed to Bubblegum, so no new account is needed per NFT and mint at the minimum cost. Makes huge free drops, ticketing, and in-game items economical. So for example, here you can see a table of cost of the official Bubblegum program. The cNFT project on Solana using MerkleTrees can be incredible cost effective with cost starting very low. So for example, minting 10,000 cNFTs will cost 0.27, total cost 0.27 Sol. So as you see, it's very, or minting 1 million will cost 5 Sol. So it's very cost effective. If you mint normal NFTs, it will cost here like 100x more or even more. Okay, so now the question for compressed NFTs, what live on chain? The idea is that the MerkleTree root and a small canopy upper level nodes will live on chain and they will keep a small account, inexpensive, account. Important, the Solana ledger, the transaction logs will handle all the leaves. The idea is to save this on the Solana RPC nodes and validators, both on chip disk space and not on the RAM-baked accounts. Data is secured by consensus, but stored on disk space, On-chain storage, EPFS, Arweave, and HTTPS. The JSON, just as traditional NFTs, the URI, the image, the traits, will live on off-chain Solana storage. So heavy metadata stays off-chain, only its hash is in the leaf, making mints 20 to 5,000x cheaper. So as we said, the idea is that the NFT data will be hashed, and you have the NFT data hashed is called leaves. Then the leaves, the node hashes its children leaves, and then the combination of nodes will hash, two nodes will hash, and will create another node. And the uppermost level, the deepest level, the last when you have no more nodes is called the root node. Where Bubblegum stores the cNFT metadata, URI, name, etc. On chain, it's only a 32-byte hash. So the name, the symbol, the URI, creator royalties is bundled into the metadata args or metadata args v2, hashed with KKK 256 and inserted as a leaf inside the concurrent MerkleTree account that Bubblegum owns. So this keeps every cNFT provable and tamper-proof while using just one MerkleTree node of space. All the JSON as we see the URI lives off-chain. You pay tiny rent on Solana but still deliver rich metadata to wallets and marketplaces. RPCs DAS indexers cache the details. Providers that implement Metaplex DAS API index each leaf, expand the hash back into readable fields and serve them through RPC methods, front-end calls, one DAS endpoint instead of reconstructing proofs themselves. Okay, so the idea is that on chain you have only the hash, of chain the JSON, and in between the DAS, Metaplex DAS API, or your own indexer. On-chain storage, the MerkleTree. The primary on-chain structure in Bubblegum is the MerkleTree, managed by the SPL account compression program. Each cNFT data's name URI is hashed into a leaf node. The MerkleTree stores only the tree hashes, not the raw data, making it highly scalable and cost-effective. Minting billions of cNFTs cost as low as 5,000 Sol compared to 12 million Sol for traditional NFTs. The leaf node. The leaf is a hash of the metadata args, including the name, URI, and other fields. This hash is stored in the MerkleTree, and the tree's root is verifiable on-chain to confirm the existence and integrity of the cNFT. Transaction logs. When a cNFT is minted, the full metadata args, data, name, URI, etc. is included in the transaction that create the leaves. This data is not stored in a traditional on-chain account but logged in a Solana ledger's transaction history. Updates to a cNFT, changing the URI or name if mutable, are similarly recorded in transaction logs as a change log. So it's saved on the ledger but in the disk space, not on the account's RAM of a validator. It's saved on the ledger but on the hard drive disk space. Core NFT fields in Bubblegum. The idea is that you have, for compressed NFTs in Bubblegum, these metadata args that are the structure in which is used during minting. This includes the name of the NFT, the URI, and other core fields are the symbol, the seller fee basis points that it ranges from 0 to 10,000, 10,000 meaning 100%. Primarily sale happened, is mutable, edition knowns, an optional field for edition tracking, creators, a list of the creator addresses, their verification status and royalty share, and the collection, an optional field linking a collection if it's verified or unverified. Hashing. When a cNFT is minted, these fields via metadata args are hashed together to create leaf nodes in the MerkleTree. This represents the compressed NFT data. NFT data storage in Bubblegum. Compressed NFTs, cNFTs, unlike traditional NFTs, where metadata is stored directly on chain in accounts, for example Metaplex or the token metadata program, Bubblegum uses MerkleTrees to compress and store NFT data efficiently. Only essential data is stored on chain, while the full metadata is logged in transactions and indexed off chain for retrieval. Key concept: the actual NFT data like the name, the URI, and other fields is not stored in on-chain accounts in the same way as traditional NFTs. Instead, it's hashed and stored as a leaf in the MerkleTree with the full data preserved in the transaction logs. So, welcome to Bubblegum version 2, just announced 3 days ago by the official, a couple days ago on May 29 by the official developers, by Metaplex, that are the official developers. The next generation of compressed NFTs is here. The idea is that more than 1 billion assets have been minted up to date, and as you see, the new features is royalties. They are enforcing on-chain royalties, permissioned. Now you can transfer, burn, freeze, and soulbound, and evolve, track, manage sets trustlessly. Royalties plugin. Royalties are now automatically enforced on-chain, ensuring that creators continually receive compensation for their work without relying on external enforcement. So the partners of this Metaplex project for Bubblegum version 2 for cNFTs are very big names like Solana Labs, Phantom Wallet, QuickNode, that is an RPC, Helios as an RPC, SoulScan and Explorer, Magic Eden, TensorTrade, NFT marketplaces, so are big names. As we see the RPCs, QuickNode, Helios, SoulScan as explorers, wallets, Solfrere and Phantom, marketplaces, Magic Eden and TensorTrade, and big names in AI and collectible. So Bubblegum version 2 is live and fully integrated into the Metaplex SDK, mint, manage and scale millions of programmable digital assets securely and affordably. So, for example, crawling through millions of transactions every time just to fetch data of one NFT is admittedly not the best user experience and is very compute intensive. Therefore, compressed NFTs rely on some RPCs to index that information in real time to abstract this way from the end user. We call the resulting RPC API, which enables fetching compressed NFTs using the Metaplex DAS API. Note: not all the RPCs support the DAS API, okay? Important to say. The idea is to create one universal NFT endpoint. Instead of juggling different RPC calls for uncompressed NFTs, token metadata, and compressed NFTs, Bubblegum DAS gives you one set of JSON RPC methods. So you can get, for example, get a set. You can get the information of an asset, get a set by owner, or get assets by owner or get assets by group that work for every Metaplex asset. Off-chain indexers to the heavy lifting. RPCs providers, big names like Ilios and QuickNode, pre-index the chain and MerkleTrees, so a single cal returns ready-to-use fields like name, image, royalties, compression status. No need to parse account data or reconstruct Merkle proof yourself. Fast, filterable data for apps. With Dash, you can pull all NFTs in a collection, the latest mints of a game, or every cNFT a wallet owns in milliseconds. Then sort or search by attributes. Perfect for storefronts, wallets, explorers, and games. Future-proof digital asset standard. Dash is part of Metaplex broader digital asset standard, aiming to be Solana's ERC-721-1155 equivalent on Ethereum. All upcoming programs, core cNFTs, and semi-fungible tokens will speak Dash, so building on it today keeps your app compatible tomorrow.